Right, so we're going to look at a histogram question to start with, and then it involves finding the mean, standard deviation, and quartiles, and some skewness to finish. Right, so when we start our question, and this is question 15 from the review exercise in the S1 textbook. So with histograms, I'll remind you then that the histogram, the frequency, I'll just put this onto the screen, okay, so it should sharpen up in the image, yeah. So our frequency equals is proportional to the interval width times the frequency density. All right, proportional to the area. Now the area will come from interval width times frequency density. All right, if you look, each bar, you work out the area. The width of the bar is the interval width, and the height of the bar is the frequency density. It may be the value of k, and we're going to work out, might be 1, so it might be a straightforward frequency equals interval width times frequency density, but it might not, so we need to check that first. So from the table of information, we can see that we've got, I'll try and arrange this slightly differently so we can see this. My first time using this technique for answering the question. So if we put that to the top corner there and we'll pull this across, then we can see that the number of students in the first interval, 5 to 10, was 10 in itself. We're not sure what k is at the moment, so we'll leave that. The interval width from 5 to 10 is 5, and the frequency density, if we look across here, is 2. So 10 equals k times 5 times 2, and so k therefore equals 1. So we'll write that there. So we've got a straightforward situation here where we can find the frequencies out if we multiply our interval width times the frequency density. So if we come across to our question, bring that back into the centre of the screen, then for the missing interval 18 to 25 we've got a width of 7, and if we come across we've got a height of 5, and so we have 7 5s, I'm sure I don't need to write that down, is 35. And then for the last interval from 25 to 40, that's a width of 15. We have a frequency density of 1, and 15 ones are 15. So that completes that part of the question. Now the second part of the question says, find an estimate of the mean time, estimate the number of people who took longer than 20 minutes to swim 500 metres. So if I go to 20 and I dot a line there, we're looking to work out the number of people represented by the shaded area. Now we know that from 25 to 40 it's 15, we've already got that. But the shaded area here is a fraction of the 35. And as we start at 20, go to 25, in an interval width that is 7, we're looking for 5 7ths of 35. Now 7 goes into 35 5 times. I'll write this a bit bigger. 5 7ths times 35, and that equals 25. So we've got 25 here, 15 there, so our estimate will be 40. Alright, that concludes the histogram part of the question. Now to calculate the mean, we're going to need a frequency table to do that. So the information we've been provided with so far, so I'm going to put it into a table like this, and I'm going to calculate the mean from that table. Now the first thing, so you'll see that you can see that the 10, 16, 24, 35 and 15, I put them into this table, copied out the intervals. Now the first thing I'm going to need to work out then is the midpoints. So between 5 and 10, if I simply add them together and divide by 2, I'll get the midpoints, and they are as follows. In fact, the final midpoints, 18, 25, we're looking at 21.5 and 32.5. And so now really the rest of this problem is calculator work. So we're going to do an fx column. I'll just pull this into the screen so we can see that. Fx, and then an fx squared column. Now I'm going to just simply not going to show you me doing that on the calculator, but I'm going to write them in. So you can sort of check with your answer if you've tried this question first, see whether you've got them right. So you're going to get 75 there, 192, 384, 752.5 and 487.5. And then for fx squared we're going to get, now just to remind you, fx squared is x times fx, so we're going to get 562.5, 12 times 192, 2304, 16 times 384, 6144, 21.5 times 752.5 gives me 16178.75, and then finally my last one will be 32.5 times 487.5, which gives me 15843.75. Now to calculate the mean and standard deviation, I'm going to need to sum my frequencies, which comes to 100. In fact, we sum everything apart from x. So the sum of fx is going to be, I'm not quite sure where I've written that down actually. I don't appear to have written it down anywhere. I think it's 1891. And yes it is. And we have to sum the last one, which is 41033. 41033. Now all the formulas I'm going to use now are in the formula book. So the mean equals the sum of fx over the sum of f, and that is 18.9 if I round it, or leave it at 18.91. And the standard deviation is the square root of sum of fx squared, 41033, divided by 100 minus the mean squared. So I can show you that on a calculator, how I do that. Sometimes we can go wrong if we don't know exactly how our calculator works, so I'll just put this on the screen and see how well this displays too. So I'm doing the square root of, I'm going to put it in brackets, 41033 divided by 100, close my brackets, and subtract 18.91 squared. Now you can see clearly the display and how I've set this out, and on this particular calculator the square root acts as a bracket. You really just need to check how yours works and be confident you can do this. I guarantee you will be asked to do this calculation in your exam. And the answer comes out then as 7.26. So standard deviation equals 7.26. And so if you practice these enough, you really shouldn't have any trouble in doing them. So the next part of the question asks me an estimate for the median and the quartiles. So I have a method for you written down somewhere, so I'll just look for that. In fact, yeah, so the method I'll remind you of is here. So what we need to work out the quartile is we need to know which interval it's in, we need to know, and then take the start of that interval. We need to know the fraction of the way through the interval that we are, and then we need to multiply by the interval width. So in the first instance, we're trying to find the lower quartile from 100 scores. You can simply divide n by 4 and look for the 25th score. So we're looking for the 25th score, and then we'll be looking for the 50th score, and then we'll be looking for the 75th score. So if we remind ourselves then of our data, then we can see that the 25th score is going to be in the 10 to 14 interval. Now there are 10 scores before it and 16 in the interval, so it's going to be the last but one score. It's going to be the 20th, it's going to be the 15th out of the 16 scores in that interval. So if I take you back to what I was just doing then, so we're in the interval 10 to 14, so the start of the interval is 10. A fraction of the way through the interval, there's 16 scores in the interval, and we're the 15th score. There's 15th score in the interval, there are 10 in the interval before it, so 15 and 10 is 25, so that's why, and that's what we want, the 25th score. And the interval width is 4. Now, you can just finish this off with a calculator if you like. 4 goes into 16 4 times, 4 into 15 goes 3 times, remainder 3, so we're looking at 10 plus 3.75, so we're looking at an answer of 13.75. Now for the 50th score, if I go back to the data again, we've got 10, 16 and 24. So the 10, 16 is 26, 24 is 50. So the 50th score is the last one in the 14 to 18 interval. So the start of the interval is 14. We are the 24th score out of the 24 in the interval. And the interval of 14 to 18 has a width of 4. 24 divided by 24 is 1, so it's simply 14 plus 4, and our answer is 18. So we now go on to the last interval, so the last quartile should I say. So we've done quartile 1, the median, and we're now on to the upper quartile. So the upper quartile will be the 75th score. So we've got 85 scores up to and including the last interval. So there's 15 scores in the last interval. So our 75th is going to be in here. Now if you've got 85 scores up, we need to go 10 back. So we're in actual fact the 25th out of 35 scores. And the interval width is 7. So if I transfer that back, then just remind myself the interval start is 18. So 18 plus 25th score out of the 35 scores times the interval width of 7. Now we can cancel 5s, go into 25 5 times, go into 35 7 times, 7 on the bottom cancels with 7 on the top, and that gives me 23. But again, if you're not comfortable with fractions, you can simply do this using your calculator. So we have the lower quartile then at 13.75, the median at 18, and the upper quartile at 23. So really we've done all the hard parts of the question, and we now come to a fairly simple part, calculating the measure of skewness. And even if you made some mistakes earlier, providing you put in the answers that you got, you'll get your answers correct here. So you've got 18.91 minus the median, which we calculated 18, divided by the standard deviation, which was 7.26. So if you use your calculator to work that out, you will come out with a score of 0.376, and so we simply describe that as there being positive skew. So to recap then, we've looked at histograms, we've looked at calculating the mean and standard deviation from a grouped frequency table, we've looked at calculating quartiles, upper, lower and the median, and we've looked at some skew. And that's the answers to question 15, review exercise.